Good day, grade 12s. I hope you are fantastic. Welcome back to another exam revision lesson with Mr. T. And as always, I'll be sharing my approach to grade 12 maths, and I really hope that this lesson will be relatable and beneficial to you. And please don't forget to subscribe to the channel and to hit the like button, okay? So, what are we looking at today? Today we're going to be going over the November 2022 DBE Maths exam. As we have been doing, we're on a series to complete the paper 1 question paper, okay? So far we've done up until question 6, and in this video we're going to be looking at question 7. All right, let's begin. Question 7 is calculus, okay? It's derivatives, differentiation, and in that we are looking at the first question, which is the first principle, okay? Now, just to provide some context for you, the first principle is basically, it was one of the first methods that were derived of, differentiation, okay? And then obviously later on, they discovered other quicker and much simpler methods, which is going to be the question 2 of this question 7, okay? So first principle, one of the oldest differentiation methods, okay? And then the standard one that you know, multiplying the exponent with the coefficient, that came later on. That is one of the easiest methods you will ever have to use in maths, generally speaking, in paper 1, okay? So in this question that we are faced with, we're going to be looking at the first principle. The question says, find the first derivative from the first principle if the equation is f of x equals to x squared plus x, okay? So how do we do this? Simple. So what I usually do is I'll copy down the formula f prime, where the limit where h tends to 0. Then I copy the formula x plus h minus f of x all over h, okay? Then from here, I work out my f of x plus h separately, which means I need to go to the equation of f of x, and wherever I see x, I replace it by x plus h. So I'm going to have x plus h squared plus x plus h. When you simplify this, it's going to give you x squared plus 2xh plus h squared plus x plus h. Okay, then from here, I get the numerator, the difference. I'm going to say f of x plus h minus f of x equals to, I take this, write it there, x squared plus 2xh plus h squared plus x plus h minus, open bracket, x squared plus x. There we go. Put brackets here as well. Then I get rid of the brackets. I'm going to have x squared plus 2xh plus h squared plus x plus h minus x squared minus, again, x. Okay? And then this will cancel that. My x will cancel that. What are we left with? We're then left with 2xh plus h squared plus h. There we go. This is your numerator, right? Then we can come back to our f of x limit when h tends to 0, and then write this down. Okay, I need to write it a bit lower. F of x, f prime x, the first derivative is limit when h tends to 0. Then we put this as our numerator all over h. There we go. Then what do we do? F prime x equals to limit when h tends to 0. Take out a common factor of h open bracket. We're going to have 2x plus h plus 1, close bracket, all over h. Right? Then I'm going to continue with it here. Obviously, this is going to cancel that, which means we can say our f prime x is going to be what? 2x plus, in place of the h, we're going to substitute the 0 plus 1. This gives you 2x plus 1. Okay, so this is how you work it out. So we took out a common factor of h in the numerator. It cancelled out with the denominator. If you didn't see it, let me just emphasize it. There it is, right? Then we were left with 2x plus h. Then in place of the h in 2x plus h plus 1, we substituted 0. When you substitute 0, then you stop writing this. That falls away. Okay, because now you are applying it. Okay, then when you substitute 0, the limit h tends to 0, it falls away. Then you just have f prime x equals to 2x plus h plus 0. Then you get your answer. There's your answer over there. Okay, now if you feel like you are not sure about your answer, you can always check, right? You can always check if your answer is correct. How do we check? One would ask. Simple. You just use your normal derivatives, right? You multiply. So we have, let me actually just copy the question first. We're going to derive this the normal way, right? So we're going to say f prime x equals to, multiply the 2 with the coefficient of 1, gives you 2x, minus it by 1, 2 minus 1 is 1, so the 1 is going to be invisible. And then we come to the x plus the exponent of x is 1 and its coefficient is also 1. 1 times 1 gives you 1. Then you minus this by 1, it's going to give you x to the power of 0. 0 is basically 1 according to laws of exponents, so it falls away. X to the power of 0 is 1, right, according to laws of exponents, which then means that the x to the power of 0 is going to fall away. You're then left with 1. So your answer becomes 2x plus 1. So after you derive using the first principle, you can always check if what you did is correct by deriving. Okay? I hope that makes perfect sense. This is very straightforward. This is going to be your step 1. This is step 1. This is your step 2, right? This becomes your step 3 here. And then that's your final answer. I hope that is crystal clear, okay? Then let's go to the next question. Next question, very straightforward. No first principle needed here. We're just going to derive this equation. So they want the first derivative. We're going to say first derivative is equal to the 5 multiplied with the 2, because it's always the exponent multiplied with the coefficient. 5 times 2 gives you 10. You're going to have 10x. 5 you subtracted by 1 gives you 4, right? Then you say minus 4 times 3 gives you 12. Then you're gonna have x. 4 minus 1 gives you 3. Then you're gonna have plus 8x. You multiply the 1, the exponent of 1 by the 8, it gives you 8. You subtract it by 1, it gives you x to the power of 0, which then means that this is gonna fall away because it just becomes 8 times 1, which is just 8. Then this becomes your answer. I think this is about 2 marks. All right. I hope that's crystal clear, that you understand it. Okay. Let's go to question 3. Question 3 says the tangent to g of x is equal to ax cubed plus 3x squared plus bx plus c. It has a minimum gradient at the point -1 and -7. Right? For which values of x will g be concave up? Okay. Now, 2 scenarios to think about here. Okay. When they say the tangent to G has a minimum gradient, right? There's two scenarios. You can have a scenario where you have a maximum gradient, right? The maximum gradient happens at the point of inflection over here. That's what it moves like. There we go. That point there. The minimum, so this would be the maximum gradient of the tangent, right? This over here would be the minimum gradient of a tangent. The minimum gradient of a tangent happens at that point. Okay? So in this case, they said the tangent to g of x has a minimum gradient at the point. There we go. Meaning that we are looking at this case, at this scenario over here. At which point, though? They said at, there we go, at point -1 and -7, right? Meaning that point of inflection now is what? -1 and -7. Do you understand? Then they said to you, for which values of x will g be concave up? Based on graph interpretation, g would be concave up here by the yellow highlighter, right? Concave up means it's facing up. It's a happy or a smiley graph, okay? So how would we write this? Using graph interpretation, we would then say x is the element of, right? As you can tell, the x coordinate, because they are looking for the x values here, right? From would say excluded, because at the point of inflection is not concave up, it's where it changes its concavity. Okay, so the point of inflection is where the graph changes from concave down to concave up and vice versa. Okay, so it's going to be excluded -1. That's why we have to exclude the x coordinate of the point of inflection. It's because at that point it's neither concave up or down. Okay, it's a flip point. Okay, so it's going to be x is the element of -1 to positive infinity. Why do we say positive infinity? Because it's from -1 going to your far right. Far right, as I have explained when we did functions, that far right means positive infinity. But again, in the exam, this question is about 4 marks, right? Which then simply means that they wouldn't give you 4 marks just for this. So what do they expect you to do? Simple. They want you to calculate it. Okay, so how are we going to calculate this? Simple. We have to derive this twice. Why do we have to derive it twice? Because the point of inflection is the second derivative of the original equation. Okay, so we're going to say g of x or g prime x. We derive this is going to give us 3ax squared plus derive that is going to give you 6x. Derive this is going to give you plus b, right? Then we derive this some more is going to be g double prime equals to that times this. I'm working that out. It gives us 6ax plus 6, right? And then now we need to work out the value of what? We need to work out the value of our a. You understand? So then I'm going to come here, say 6a open bracket. Remember, what's the x value at the point of inflection? The x value at the point of inflection is -1. We put the -1 here. Then we say plus 6. Now, the g double prime is not the y coordinate of the point of inflection, okay? It's the point of inflection. So the point of inflection is always 0. So then we're going to say 0 is equal to 6a, open bracket, -1, close bracket, plus 6. Okay, so the g double prime x, don't get it confused. It's not the y coordinate of the point of inflection. It is the point of inflection, which is 0. Okay, then from here, we just work this out. It's going to give us -6a plus 6. We transpose the 6 to the other side. It's going to give us -6, -6a, divide by -6. This cancels that. Therefore, our a becomes +1, right? Now, we have to work this out, right? We have to calculate what our x values are, right? They said concave up. If it's concave up, it means our point of inflection has to be greater than 0. If it was concave down, our point of inflection, this is concave up, and then for down, it would be G double prime less than 0, okay? But now we're dealing with up. So, quickly, let me just do this. We're then going to put everything in our formula, because we need the formula of the point of inflection equals to, is going to give us 6. If A is 1, you multiply, let me maybe write it here where I can see it properly. So G double prime X is going to give us 6. In place of A, we have 1x plus 6. This gives us 6x plus 6. That's our point of inflection formula, right? But now they're saying this point of inflection has to be greater than 0, meaning we're going to take this formula, just substitute it there, right? To calculate the values of x, whereby G is concave up. So we're going to have 6x plus 6 greater than 0. Transpose the 6 to the other side. Negative 6, divide both sides by 6. This cancels that. I'm just going to erase this. X is greater than negative 1. Which, if you write it in terms of a domain, it would be X is the element of excluded negative 1 to positive infinity. Exactly what we had before. There it is. You can say O here. There we go. Okay, so this is how you work out this question. If they say a tangent has a maximum gradient or a minimum gradient, you work it exactly how we did with this one. Okay, I think this is going to be it for question 7 of this paper. And again, like I always say, if you have any questions, just drop the questions in the comment section, and then I'll get back to you as soon as I can. Okay, we are almost at the end. We just left with, I think, like 3 more questions. We're almost done with the November 2022 paper 1. As soon as we're done with this, we're going to go straight into paper 2 and then cover many more past papers. Okay, I'm really excited to release more material for you guys, and just to hear what you guys think about the service that we offering to you guys. Okay, I think this is going to be the end of the lesson, and yeah, man, till I see you again, bye.